Assalamu alaikum students. We have started last time discussing strengths of magnetic field around a current carrying conductor. Today we will see some aspects of magnetic field, the factors affecting and some simple calculations related to calculating magnetic field in a solenoid. So strength of a magnetic field, as mentioned in the note, depends on three main factors: the number of the turns if you are using solenoid, otherwise if you have only one turn, that is a loop. Okay, the difference between loop and solenoid: a loop is one turn, simply it's one turn. What that means, one turning of a coil, only one turn of a coil. It's better than using straight line coil because it increases the strength of the magnetic field, we have said. So a number of turns, if you have used a number of turns, that means you will use, that is, we call this one is a solenoid. So if you have number of turns, so it is a number of turns we make increases the magnitude of the strength of the field. The other is permeability of the free space, which is mu naught, okay, and its unit is Henry per meter. Okay, permeability of free space, which is mu naught, its unit is simply Henry per meter, or H per M. And the other is the current through the wire. The current through the wire, if the current is high, that means the current means the flow of charge is enough, or higher amount of current is flowing, so the strength of the field will be high. Okay, obvious. So we have two important formulas. One, B is equal to mu naught I over 2r when we are using loop, one single loop having a radius of r. So mu is the permeability, I is the current, r is the radius of the loop. Okay, the other formula is B is equal to mu times n times I. Okay, mu times n times I, that means the number of turns. By the way, the number of turns it should be the number of turns per meter, that means per unit length. Okay, that is why the magnetic field strength inside a solenoid per unit length of the solenoid, per unit length of the solenoid. That means if you have given number of turns and you have given the length of the total length of the solenoid, we have to divide. Okay, we have to divide the total number pi by the length. This is the way to calculate n. Okay, sometimes n will be simply given, sometimes what will be given is simply the number of turns and the length, the total length of the loop. So you have to calculate n by calculating, that means dividing the number of turns over the length. This is n over L. N means the number of total turns over L. So small n is number of turns per unit length. This is important. So it is given here, mentioned. Work out the example in 4.3 in your page 130 of the textbook. So it is simply mentioned there. Okay, to go through simple highlight of the example, it says a solenoid has 1000 turns per meter. It is given already, small n, okay, because it is turns per meter, it is already a small n, not capital N, and has a current of 2 ampere passing through it. Work out the field strength, that means the magnetic field strength at its center. That means at its center means inside the solenoid. If given it is inside the solenoid, if it is loop, you have to be given what? The radius. The permeability of the free space is 4 pi times 10 raised to minus 3 Henry per meter, or H per M. So simply substitute the value to the formula. Okay, B is equal to mu times small n times I, current. Okay, 8 pi times 10 raised to minus 4 Tesla. T is Tesla. The magnetic field strength is measured in Tesla, we have said. Its unit is Tesla. Let us see somehow different example. Okay, a little bit. Here what is given in your note is what is the field inside 2 meter long, okay, inside 2 meter long solenoid that has 2000 loops. Look, this is what, small or capital N? It's capital N. 2000 loops and carries 1600 ampere of current. The way to solve this problem is a little bit different, okay, from the first example. What is different here is, first you have to calculate N. You have to calculate N because small n is not given. So 2000 number of turns over 2 meter, which is the length of the total length of the loop, that means the solenoid, it is 1000 per meter. It's 1000 turns per meter, or simply 10 turns per centimeter. Okay, 10 turns per centimeter. Each centimeter of length has what? 10 turns, or each meter of length of the coil, that means has 1000 turns. So the solution is simple. B is equal to mu n I 4 pi times 10 raised to minus 7 times 1000 times 1600 ampere. It is 2.01 Tesla. Okay, 2.01 Tesla. It is very much, that means by a higher amount is greater than the first we have solved in your textbook. So the magnetic force can be calculated easily here. If you get the magnetic field, what we need is a magnetic force. This force is the one we need. Why? We want to do a work. You know that work is force times a distance, simply. Force times a distance. So we need a magnetic field to do some work in a machine, in a computer, in a television, any machine or technology. That is why we need the force. The force is simply B times I times L. Okay? B is the magnetic field strength, I is the current, L is the length. Okay? The length, which is 2 meters in our case. So 2 times 2.0201 times 1600 times 2, which is equal to 6432 Newton of force. This force can do a work if it makes some motion. Okay? Now, here by the way, the force formula is BIL sine of theta. What is theta? Theta is the angle between the magnetic field and the current flow. The magnetic field and current flow both have their direction. So the angle between I and B is theta. So this theta for this case is not considered. Why? Because it is considered to be right angle. Right angle, which means 90 degree. You know that sine of 90 degrees? 1. That is why it is simply ignored. Otherwise, okay, the general formula for the force is B times I times L times sine of theta. Theta is the angle between magnetic field and the current. Now I will give you one question. Work out example 4.2 of page 129 in your book and compare the force with this value. Okay? Compare the force where in that example with this force. With this force, which is 6432 Newton. And tell me why is the difference. Okay? What is the reason behind with this difference? There is a big difference between this force and that force. And tell me the basic reason for this difference. Okay, see you in the next or the other video. Okay, thank you so much.